On November 11th, 2025, an X5.1 class solar flare erupted from the sun's surface, triggering a geomagnetic storm severe enough to paint the night sky with aurora across latitudes that almost never see them. It was the third strongest storm of this entire solar cycle. And according to NOAA's own space weather forecasters, even though the sun has technically passed its peak, 2026 could still bring more of exactly this kind of intense activity. Here's what's actually happening on the sun right now, and why scientists are watching it so closely. This is the real, verified story of the sun's current activity, straight from NOAA and NASA's own space weather data. If stories about the sun's genuine, verified activity fascinate you, hit subscribe now, because we break down real space weather science every single week. Let's start with understanding exactly what's driving this elevated activity, because it all comes down to a natural, well-documented cycle scientists have tracked for centuries. The sun moves through an approximately 11-year cycle of rising and falling activity, called the solar cycle. Our current cycle, solar cycle 25, began back in December of 2019. In October of 2023, NOAA's Space Weather Prediction Center revised its official forecast, concluding that this specific cycle would peak faster and reach a higher level than originally predicted back in 2019. That updated prediction called for the cycle to peak sometime between January and October of 2024, with a maximum sunspot number considerably higher than the original, more conservative estimate. That revised forecast proved accurate. According to NASA, solar cycle 25 peaked early, with sunspot counts and solar flux reaching their highest level since 2014 by early 2024. Here's exactly why that peak hasn't met a quiet sun since. Like this video right now if you want to understand exactly why solar activity remains genuinely elevated, even well past the cycle's official maximum. According to Space.com's most recent solar activity analysis, published in December of 2025, the strongest solar flare of that year, an X5.1 class event, occurred on November 11th. That same event produced the third strongest geomagnetic storm of the entire solar cycle so far, reaching G4, or severe, levels on NOAA's official storm intensity scale. For context, NOAA's geomagnetic storm scale runs from G1, considered minor, up through G5, considered extreme. In 2024, the sun had already produced two even more powerful storms, a G5 extreme event in May and a G4 severe event in October, each one producing widespread dramatic aurora visible across much of the world. Here's the specific detail that matters most for understanding 2026 specifically. Don't forget to subscribe before we get into it, because this directly addresses whether the sun's declining phase actually means declining risk. According to Space.com's analysis of the sun's recent behavior, even though solar cycle 25 has now moved into its declining phase, that doesn't mean the chances for strong flares or severe geomagnetic storms are over. Researchers specifically point to historical precedent from previous solar cycles to explain why. Solar cycle 23, which peaked back in 2001, produced 10 separate flares above the X10 classification level, and remarkably, 4 of those extremely powerful flares occurred in 2003, fully 2 years after that cycle's official peak. The single largest flare from that entire cycle, estimated at an extraordinary X140 classification, actually occurred during that same later period, so powerful it exceeded the sensitivity of detection instruments available at the time. That historical pattern is exactly why NOAA and NASA researchers continue closely monitoring the sun throughout 2026, despite the cycle technically being past its peak. Strong individual events, sometimes among the most powerful of an entire cycle, have repeatedly occurred well into a cycle's declining phase throughout recorded solar history. Let's look at what's actually been happening on the sun specifically throughout 2026, because current, verified data confirms this elevated activity has genuinely continued. According to space weather tracking service EarthSky, sunspot numbers in early 2026 have remained meaningfully elevated compared to the notably quieter years of 2019 and 2020, when this current cycle first began. Space weather reporting from May of 2026 specifically documented multiple X-class and M-class solar flares erupting since the start of the year, along with a coronal mass ejection event that interacted with Earth's magnetic field, producing a moderate G2 geomagnetic storm that surprised forecasters by intensifying somewhat more than initial projections had suggested. Here's why this ongoing activity carries genuine practical significance beyond simply producing beautiful aurora displays. Make sure you're subscribed, because understanding the real infrastructure implications here matters considerably more than any dramatic headline framing. Coronal mass ejections, when specifically directed toward Earth, compress our planet's protective magnetosphere and can drive the kind of geomagnetic storms capable of genuinely affecting modern infrastructure. According to space weather analysis published by Beyond Tomorrow in May of 2026, even a relatively moderate G3 storm can force satellite operators to conduct manual reviews of collision risk warnings and require power grid operators to reassess transformer loading calculations that weren't originally scheduled for that specific day. The most historically significant example of this kind of impact remains the March 1989 geomagnetic storm, which caused a widespread power grid failure across Quebec, Canada, a real documented case study space weather forecasters continue referencing when assessing genuine infrastructure risk today. More recent events throughout 2026 have specifically demonstrated these practical impacts, though generally at a considerably more limited scale. According to reporting ON, this year's coronal mass ejection activity, several recent solar storms have caused what experts specifically characterize as manageable disruptions rather than catastrophic failures, including interference, with high-frequency radio communications and specific rerouting of some polar aviation routes. Since solar storms can interfere with the radio communication and navigation systems airlines specifically rely on for these northernmost flight paths, there's also a genuinely interesting connection between this ongoing solar activity and NASA's own human spaceflight program worth understanding. According to reporting from earlier in 2026, a powerful solar flare specifically triggered radio blackout concerns during preparations connected to NASA's Artemis II mission timeline, with scientists closely tracking the associated coronal mass ejection, specifically due to its possible trajectory toward Earth. Astronaut safety becomes an increasingly significant consideration during periods of strong solar activity, since elevated radiation levels associated with major solar events pose genuine, well-understood risks to crews operating beyond the protective shielding of Earth's atmosphere and magnetic field. Here's the more visually spectacular side of this same ongoing solar activity. Because increased storm frequency directly translates into increased aurora visibility for skywatchers around the world. Like this video right now, if you've been hoping to catch the northern lights yourself, because current solar activity genuinely favors your chances. According to Space.com's analysis specifically addressing aurora prospects for 2026, stronger solar activity means aurora displays become visible at considerably more southern latitudes than usual, allowing skywatchers throughout parts of the UK, the United States, and numerous other countries that don't typically see the northern lights an unusually good opportunity to witness this phenomenon. That happened repeatedly throughout 2024 and 2025, and current solar activity trends suggest 2026 will likely continue offering similar opportunities, even as the underlying cycle continues its gradual longer-term decline. It's worth understanding exactly how NOAA and NASA continue monitoring all of this activity in genuine real time, since that ongoing monitoring is precisely what allows for the kind of practical, actionable warnings that protect both infrastructure and astronauts. NOAA's Space Weather Prediction Center issues regular geomagnetic storm watches and alerts, drawing on continuous observation from NASA's Solar Dynamics Observatory and other dedicated space. Weather monitoring instruments, tracking solar flares, filament eruptions, and coronal mass ejections as they occur, then modeling their likely trajectory and potential Earth impact well before any resulting geomagnetic storm actually arrives. Official NOAA solar cycle progression data, updated monthly as new observations become available, currently projects a continued elevated, if gradually declining, sunspot activity throughout the remainder of 2026, with numbers expected to continue trending downward through the back half of the year as the cycle proceeds through its natural expected decline phase. Let's take a closer look at exactly how solar flares get classified, because understanding this scale helps put terms like X-class and M-class into genuine, useful context. NOAA classifies solar flares using a letter and number system based on the intensity of X-ray radiation each flare produces. The scale runs from A, the weakest, through B, C, M, and finally X, the most powerful classification. Each letter represents a tenfold increase in energy compared to the letter before it, meaning an X-class flare releases 10 times more energy than an M-class flare of the same numerical value, and 100 times more than a C-class flare. Within each letter category, the number indicates relative strength, so an X5 flare is roughly 5 times more powerful than an X1, while an X9 event, like the strongest flare confirmed during Solar Cycle 25's more active earlier period back in October of 2024, represents genuinely extreme solar activity. It's also worth understanding exactly what a coronal mass ejection actually is, since this term appears constantly in space weather reporting, but represents something genuinely distinct from a solar flare itself. A solar flare is an intense, localized burst of radiation and light, traveling at the speed of light and reaching Earth in about 8 minutes when Earth-directed. A coronal mass Ejection, by contrast, involves the sun actually ejecting a massive cloud of charged particles and magnetic field directly into space, traveling considerably slower than light itself, typically taking anywhere from about 15 hours to several days to reach Earth, depending on the specific eruption speed. That difference in travel time is exactly why NOAA's forecasters can often provide advance warning before a coronal mass ejection actually arrives, giving satellite operators, power grid managers, and airlines genuine actionable lead time to prepare for potential impacts. There's also a valuable practical dimension worth understanding regarding how everyday people can actually track this activity themselves, rather than relying solely on secondhand reporting. NOAA's Space Weather Prediction Center maintains publicly accessible real-time data and forecasts, including specific aurora visibility predictions based on current and forecasted geomagnetic activity. Numerous space weather-focused websites and mobile applications now provide accessible, continuously updated alerts specifically designed to notify enthusiasts when aurora visibility extends into their specific geographic region, technology that has made following this kind of solar activity considerably more accessible to the general public compared to just a decade ago. Looking specifically at what the remainder of 2026 is likely to bring, official NOAA solar cycle progression modeling continuously updated as new monthly observations become available. Currently, projects gradually declining, though still meaningfully elevated, sunspot activity through the year's second half. That projected decline reflects the natural, well-understood progression of the roughly 11-year solar cycle, even as historical precedent from previous cycles specifically suggests genuinely powerful individual flares and storms remain entirely possible throughout this declining phase, rather than activity simply stopping abruptly once the cycle's technical peak has passed. For now, the sun remains genuinely active, producing real, NOAA-confirmed geomagnetic storms, real X-class solar flares, and real documented impacts on satellite operations, aviation routing, and crewed spaceflight planning throughout 2026. That activity, while genuinely significant and worth continued, careful monitoring by space weather professionals, has so far produced exactly the kind of manageable disruptions those same experts have specifically described, rather than any kind of runaway, uncontrolled crisis. Understanding the real, verified science behind these events, rather than relying on dramatic, unsourced framing, remains the best way to appreciate both the genuine beauty and the genuine, well-managed risk. This remarkable natural cycle continues to produce. If this story helped you understand the real science behind the sun's current activity, make sure you're subscribed, because we break down verified space weather science every single week. Hit like, drop a comment letting me know if you've caught the northern lights recently, and I'll see you in the next video.